So let us now load the program into the CPU and see it running. So if you haven't done this already, go ahead and open up your Logisim executable and then open up the Design a CPU 2 circuit file. When you've opened that up, go down to CPU_test and double click this here. Now whenever you've double clicked this, you should now be in this file here, so it should all be opened and ready to go. So the first thing you want to do is make sure that we're in simulation mode. So if you click on simulate, we want to have a little tick in here. So if you click on this, you'll see the little tick appearing, and this is simulation enabled. We also want to make sure that we're actually on the little finger here. So the first thing to do is press the reset button here. So this is reset here. And now if we want to reset the entire CPU, we have to press this reset. So that's the CPU completely reset and it's ready to receive information. You can notice that all of the registers have gone to 0. And if you get inside the CPU, you'll see that every single connection is either a dark green, which is a 0, or a light green, which is a 1. There aren't any blue lines and there aren't any red lines. If there were any blue lines, it would mean that the CPU would be sitting at a value that it didn't know. If there was a red line, it would mean that there was an error somewhere. So everything should be dark green and light green. So let's go ahead and we'll load in our program. So we load in our program here from our external RAM. So if you right click the RAM and you go down to edit contents, you can then press the open button and it will open up a folder. So find the mysim file which we've just generated. Now if you click on that, press open and then press the close window, you'll see that it's actually loaded in the values here from our program. So this is the 20, the 1, the 21, the 1, the 81 and the CF. Now we know what these are. This is our add the value 1 into register R0, that's the value 1. This is add the value 1 into register R1, that's the 21, and this is the value 1. And this 81 is the add R0 R1, and the CF is the end, so we know what these are. So now what we can do is we can actually load these values into the CPU. So if you press the simulate button and you click on the tick enable, now you'll see that this starts to run up and it'll count up to a value of FF, which is the 256 memory cells. Now what we want to do is stop it just at around about the value FF. So just about here. If we stop it here, we're at FC, and what we'll do is we'll actually click through the last few clock pulses to get to the value FF. Now you don't always have to do this. I'm only doing it this once so that you can see exactly how we load everything up. You could just allow that to run and it would run through the actual program. So let's go ahead and we'll make sure that we've actually loaded everything in. So if you go into view CPU, now I'll actually go on a different screen here so as it makes it a bit easier to see. Okay, right, that's us. That's a bit easier. So if you get into the RAM, you'll see, if I zoom in a little bit here, you can see that we've actually loaded up the RAM with the code. So the first RAM elements are actually, if I zoom down a bit here you might see it. Okay, so you can see here that we've actually loaded in, and this is the first RAM cell here, and we've loaded in this value here, right, and then the value 1. So this is our data R0, and this is the actual data value 1, and this is the data R1, and this is the value 1, and this is the add instruction, and this is the end instruction. So these are our 1, 2, 3, 4, 5, 6 bytes of our program to add two numbers together, and they're sitting here now in the 256 byte RAM. So we're now in a position where we could actually step through and check and see that these values here do actually match up with the values that we're expecting to see in the program, the assembly language debugger that we have created, that is the simulator. So let's go ahead and we'll do that now. So on the top of the screen here we have our CPU, so that's just our normal CPU page, okay? On the bottom of the screen we have our assembler debugger, or if you like to call it, our little simulator. Now what we want to do is compare the values here for the registers and the flags with the values for the registers and the flags here and see that everything matches. Now one thing to note, that on the program here, the values here are actually the decimal values, but the values up here are in hexadecimal. So what I've done is I've created another screen here just called debug output in hex. So if you click on that, that actually gives you the value of our outputs, but it gives you it in hex. So I'll zoom in a bit so we can see that a bit better. So that's the registers, and that's the value that we expect to see in the registers in hexadecimal. So we have the instruction address register, instruction register, the R0, 1, 2, 3, 4, and then all of the flags. So let's go ahead. One thing to note is that it's going to take a certain number of clock pulses to run through this in order to go through one fetch execute cycle for each instruction. So let's have a look inside the CPU, and we'll see how many clock pulses we're going to have to work through in order to go through the first instruction. So if you get into the CPU and you get into the control section, you'll note here that we have the stepper. Now the stepper counts along from 1 to 7 and then goes back to 0, and we've seen from the previous course that what happens here is that it fetches in the first 3 cycles and then it executes on the next 3, and then it heads back to the beginning again. So we know it's going to take 4 clock pulses to go through from position 1 to 2, and it takes 4 clock pulses to go through here, so it's going to take 4, 8, 12, 16, 24, 4, 8, 12, 16, 20, 24. So it's going to take 24 clock pulses to go through one fetch execute cycle. So it should take 24 clock pulses before we actually see the values that we expect. So let's work through and we'll step through these 24 clock pulses. So go back to the top level here, which is CPU test. Now in order to go through the clock pulses, if I open this up here, we can go through every single clock pulse just by pulsing here. So I'll go through the first 24 just now. Okay, so that's 24, so that should have been completed the first instruction. But it's actually going to be 3 or 4 clock pulses further along before it actually gets to the point that we're interested in here in our simulator. So let me just find this value here. So we should have 2, 21 and 1. So let's go ahead and we'll get to that point. So there we have it. We have 2, 21 and 1, and these registers here are values of 0. So let's open up the spreadsheet here and we can see that's what we have. We'll get 2, 21 and 1. So that's as we expected. So that's all that's done is it's loaded the value 1 into register R0. Now we're not so much interested here in the flags, and this is the thing to note here, that this here is a simulator, it's not an emulator. We're not interested in every single value of the flags here. We're only interested here in the values of the flags whenever we're going to do an arithmetic operation. So there will be other values here for the flags that will be set, and generally whenever we do an arithmetic operation we will clear the flags. Now we haven't done that in this instance, but we will do it in future programs. So we have 0 here at the moment for all of these flag settings, and we only have an output of the flag whenever we actually do the add instruction, and it'll give us a equals b flag. So let's go and we'll find the next instruction. So the next instruction is going to be 24 clock pulses further on from that point. So you can jump in 24 clock pulses. So this is 4, 81, 1 and 1, and that's what we've got here, 4, 81, 1 and 1. So that means that this simulator here is actually modelling the CPU, and you can work through the final code here will be 24 clock pulses further ahead. And that's the final clock pulse here, and you can see it's reading in the value CF, which will be the very final end command. So let's have a wee look and we'll see that that's the case. So we're going to have 5, we're going to have CF 1 and 2. So it has added the two numbers together and it's put the value into R1, and it's also set the flag here A equals B, because in this instance the value for A and B are going to be 1 and 1. So you'll note that this little end button has turned red. This tells us that we're now at the end of the program. So we've worked through all of the instructions of this program. Now let's go ahead and we'll reload it in, and we'll just allow it to run at full speed. So if you go in here, and we have to be very careful about how we do this, we want to go in and press first of all the reset here, and then we want to press the reset here. If you didn't press this reset up here, is a chance of the whole of the design here getting into an unknown state. So let's load up the program again. We go into the external RAM, we right click, edit contents, and we press open. We pick our file, which is MySim, we press OK, that's it loaded up here, close the window, and now we're ready to start again. So in order to start, we click simulate and we just press the tick enable, and this will allow it to run through the program itself. We don't need to continually press this clock here. So you can see it counting through here. If you drop down in, you'll see actually all the wires running through, everything changing. Let's head back to the top level again, and once this has got to FF, it will have loaded up the entire RAM, and then you'll see the actual code getting run. And there we go, 1 in R0, 1 in R1, and then it adds up and you get a value of 2. Finally, the stop command you can see is CF, and you can see the little red lights going on, but we see this is still clicking away. So what we want to do is go simulate and tick enable, and that stops it. So again, if we wanted to run this again, we would have to go into simulate, reset, press reset, right click, edit contents, open our file, that's our file open, close the window, and then again tick enable, and that would run through it again. So that's the process we would go through whenever we want to run the actual code on the CPU. So this is the reason why we wanted to make sure that we had a method of simulating the code on Excel. Once the code is simulated in Excel, we can work through very quickly and use the debugger to make sure we've got our simulation or assembly language program correct, and then we can come and load it into the CPU. Once you've run through the process of designing assembly language programming, outputting it, and then loading it into the CPU 2 or 3 times, then you get quite adept at it, you get quite quick, and it's quite an easy and simple thing to do. What I suggest you do is you open up and you actually try running the program But what you can do is you can step through the code individually and you can check and see within the CPU all of the changes that occur as you work through that simple addition. So thank you for listening. On the next videos we'll get on to some more complicated assembly language programs, and from those more complicated programs it'll start to throw up the problems we have with this CPU, and we're going to start working at other solutions that we can have in order to build in the CPU and make it better and make it able to do a lot more things for us. So thank you for listening. I'll get you in the next video. Goodbye.